Everybody, today we'll begin with the chapter Heat Transfer and we will be studying about conduction of heat. As we know, is a form of energy which makes a substance hotter. We can define heat as the thermal energy in transit. The thermal energy moves from one place to another by virtue of the difference in temperatures. We can have three modes of heat transfer. First is conduction, convection, and radiation. Let us take the process of conduction. When heat is transferred from one end to the other end without the actual movement of the molecules or the particles of the metal, it is known as conduction. Thermal conduction plays an important role in our daily lives. Heat passes through solids by the process of conduction only. The second process is convection. It involves the movement of the heated molecules. It is the process in which heat is transmitted from one place to other by the actual movement of the particles. It is prominent in the case of liquids and gases. The third process of transfer of heat is radiation. In this process, heat is transmitted from one place to other directly without the intervening medium. We get radiation of sun without any medium. Heat radiations therefore can pass through a vacuum. Their properties are similar to that of light and they are also a part of electromagnetic spectrum. Energy from the sun comes us through the process of radiation. So from here we can note that conduction is a slow process and the radiation is the fastest because the transfer of heat takes place at the speed of light. Both conduction and convection require a medium for the transfer of heat. Conduction. As we know that heat conduction is the transfer of heat from the hotter part of the material to the colder part without the actual movement of the particles. During the heat conduction process, heat energy is transferred only to the successive molecules and the molecules do not leave their mean position. One end of a metal bar is heated, molecules of this end begin to vibrate faster. These particles at the hot end have a greater kinetic energy of vibration in comparison to the particles that are not directly under heat exposure. These moving particles or molecules collide with their neighboring molecules and transfer their energy to these molecules. Now let us consider some terms related to conduction. For this, we'll consider a solid metal bar and one end of the bar is heated. So this end is at a higher temperature as compared to the other end which is at a lower temperature. So P is at a higher temperature and Q is at a lower temperature. So if we start providing heat at end P, then each section of the bar gets heat from its adjacent previous section. That is, section C will get heat from section B and B will get heat from A. Again, let us consider the sections A, B and C. As B gets its heat from section A, some part of the heat received is absorbed, due to which temperature of section B increases. Some part of this heat received flows to the atmosphere and the remaining goes to the adjacent section C. In this state, temperature of every cross-section of the bar increases with time. This is known as the transient or variable state of heat conduction. With the passage of time and continuous supply of heat, a state is reached when the temperature of each and every section becomes uniform, and in this state, no more heat is absorbed by any section of the bar. So the temperature of each cross-section becomes constant, and we call it as the steady state or the stationary state. By steady state, it does not mean that the temperature of the whole rod is same. In this, the temperature of different parts of the rod is different, but the temperature at each part, whichever it may be, remains constant. So in other words, we can say the rate of change of temperature at this part remains constant. The temperature decreases as we go away from the hotter end. The loss of heat to the atmosphere can be prevented by covering the rod by some non-conducting material. Then, in the steady state, heat received by any section will be totally transferred to the next. In this state, the rate of conduction of heat in the rod will depend only on the conductivity of the material of rod. Isothermal surface. The surface at every point of which the temperature is same is called as an isothermal surface. The next term is temperature gradient. The rate of change of temperature with distance in the direction of flow of heat is known as temperature gradient. Now let us consider the following diagram. In this section, P and Q are the isothermal surfaces. The temperature of these cross sections is same. Let delta x be the normal distance between these two surfaces. Now the temperature, as you can see, of section P is greater than that of section Q. If T plus delta T is the temperature of section P and T is the temperature of section Q, then the temperature gradient is equal to the change in temperature divided by the normal distance between them, which comes out as minus delta T upon delta X. The temperature gradient is positive in the direction of increasing temperature since the heat flows from higher temperature to the lower temperature. The temperature gradient along the direction of heat flow has a negative value.